Okay, so just a quick update on where we are with the driller retro remake. Made some good progress today, mainly thanks to the works of John Elliott and Stephen Henk-Don, who've done a lot of diligent work in getting into the details of the Freescape command database format in the Spectrum. As I said in my previous post, it brought back a lot of memories and reminded me how it all worked. It was very useful as a kick-off point. So just to show you what we're looking at here, this is a driller running in a Spectrum emulator. So if I just quickly start, you can see just how much fun it was. Very slow, but still impressive for the day. Have the ability to switch to mouse mode, so you can fire on things, make things happen. That's basically what we're looking to reproduce. So the way I've done this so far is to take a memory dump of this running. If you look in the memory, in the file menu, there's an ability to save a snapshot, which is literally a memory dump of the 48k of memory with some extra information in there that can be reloaded in to restart the machine from the exact same point at which you took the snapshot. So I've saved that out previously, and then I've written some Python code based on some of the ideas from John Elliott and others, which basically reads in the binary file and interprets it based on the data that we know, that the structure that I know the database is in, using Python's convenient struct unpack features, which allow you to interpret binary data and bring it in as data structures that are more readily processable by Python. So this basically goes through each room in the snapshot from the address that I know the database is stored at, and then goes through each object within each room and creates all of the different object types: lines, pyramids, rectangles, etc. Outputting a bunch of data in JSON format. JSON because it's much more easy to process in GD script. Godot has built-in ability to built-in functionality for dealing with JSON files. So this is an example of one of the rooms, the Amethyst, the starting room, which I'll show you in a moment in Godot. So it's just a JSON file, a bunch of header stuff about the game in particular. Not using much of that at the moment apart from the name, but then there's a list of objects. Each object has a location and a size, the axis aligned bounding box effectively, a unique ID which is used for the command language to identify it for script control, a type, and then a bunch of other data. So the other data changes depending on the type. So materials, there are 6 materials for a cube, with find something different. A rectangle has just 2 materials. I'll get to bytecode in a second. There's pyramids as well somewhere down here, if I can find one. Pyramid. So a pyramid has a cap which identifies the 2 additional points on the peak of the pyramid and how they differ from the bounding box. So that allows you to create a variety of different pyramid type shapes. And then in addition, some of them have bytecodes. So this is the FCL command language, a very simplistic command language for controlling the game and implementing the logic in the database. So these are just directly translated from the bytecodes in the memory dump. I'm not doing anything with them here. I'll do all the work in Godot, which I'll show you in a moment. So if we go to Godot now, in here I've created a script that reads in that JSON file for a single room. Each room is dumped out as one JSON file, then creates all of the objects and other parts using the polygon mesh primitives that Godot provides. So it is exactly reproducing the original scene, and this is what it looks like when it's loaded in. So this is Amethyst loaded in. It's got a variety of shapes in here: quads, rectangles, which are different. The rectangle is always aligned axis to the axis. It has no way of changing orientation, so a quad allows you to have effectively rectangles that are a bit more flexible. Pyramids, cubes, a few other things. I've added a couple of lights in here just to make it a little bit more interesting, so you can actually see. So there's a simple directional light that's casting some shadow, and then an omni light in the middle here, which adds some detail. So you can see if we turn that off, it's all very flat. So I just added that in just to give it a little bit more depth and detail. On the objects themselves, you can see each object is created as an object with a mesh and collision information and various other bits and pieces programmatically by that room script I showed a moment ago. It also brings in the bytecode, so it's associated with the object. Particularly interesting one is the cube over here, which you saw in the spectrum toggles the door on and off. So this one, go to the parent object, and it has just a very simple 4-byte program. 13110 1565. So these programs run in such a way that depending on the top bit of the instruction byte, this one here, defines whether it runs that instruction if you shoot at the object, if you've hit it with the lasers, or if you've collided with it and run into it. So it allows you to do the same thing effectively with a single instruction, but just by toggling the top bit defines when it actually happens. So just to show what this one does, 131, if we go and have a look at the FCN interpreter script, which I've started writing, 131 is opcode, it's up here, togviz, and because the top bit is set, it's 83, not 03, it means it will trigger when the object is fired upon. So that will togviz object 10. So if we just look down, object 10, go back to the 3D view, object 10 is our door, which is currently invisible because it starts off invisible according to the data. So if we now run the game, I've created a very simple FPS controller so I can walk around and collide with things. It all seems to work, so you can actually bump into the wall, get through the wall, etc. But most interestingly, if we go to that cube over here and then bring our mouse pointer back, look down here, this is where the output is processed for debug. And if I click on that, you'll see the actions actually work. It's printing out the commands. The game in the background, the noise in the background is actually the Spectrum emulator telling us that we've been sitting around for too long and the baddies have come to get us. So I'll just put that to sleep for a minute because that'll get very annoying. So that works, and it just prints out the output here, and you can see there are others. So if we just move around to here, the wall will invisibilize itself. It will play a sound if there was one, and it'll add to the score. Similarly here. So all of that is just working just by pulling in the data from the original Freescape database. We can get rid of that as well. That would have invisibilized both the door and the building, and play a sound if we were playing sounds. So that's where we are. And just to show how it works, so if I come back into the Godot editor and come back up, you can see what we've created is a self-contained object. These are all the objects that are loaded in from the JSON file. And just to show you how it might work, so if I duplicate this scene, and we'll call it something else, open that one up. You can see up at the top here, this is the main object that controls the room. It's currently loading in data from amethyst.json. If I load in a different one, so if I load in Nicolite, for example, and then click this, it'll regenerate the scene from the JSON that it's just loaded. So you can see we've got all of the same capabilities in there. There's some work over here for a switch, which will have some bytecode on it, I'm sure, some fairly complex bytecode, most of which won't work at the moment because the instructions aren't implemented, but it all comes in. So the plan would be to have in a main scene each of these and all of the different rooms loaded in simultaneously, because we can cope with that quite happily on a modern machine, and just toggle between them as you travel from room to room. I think that's it for now. Try and come back with another update in the next couple of days. Thank you.